Hey, this is my recording for the solution for homework 6. The first one is activity 24.3, talking about Alan and Bob mowing a rectangular lawn. So they mowed 3/4 of the lawn, so I drew the lawn and divided it into 4 parts and shaded the 3 parts that they mowed together. When they stopped, Alan had mowed 2/7 of what Bob had mowed, so that means Bob had mowed 5/7 of the yard. So, when to make a diagram of how much each boy mowed, so this darker stuff is what Alan mowed. So he would have mowed 8 out of the 28 pieces, or 2/7, and then Bob mowed the 5/7 of what they mowed, of what was left. I'm not sure that I have the 13 right because I know I've changed it several times. So the area that Bob mowed is 1.5 times larger than the area that Alan mowed. And I got that because if Bob mowed 5 of the parts and Alan mowed 2, well, double of 2 would be 4 plus another half would be 5. So I got 1.5 times for that. Alan mowed 8/28 of the total lawn area, or 8 pieces out of the 28 pieces, or 2/7, if you simplify that. The ratio of the area of lawn Bob mowed to the area Alan mowed is 5:2. And if they were paid a total of $18 for the work they did, how much money should each boy get if they were paid proportionally to the amount they worked? So I took the 2/7 and I multiplied that times 18, and I got $5.14 for Alan, and then I did 5/7 times 18 for Bob, and I got $12.86. The next one, activity 25.5. I will not lie, this one was hard for me, and I'm still not completely sure that I have it right. In fact, I'm pretty sure I don't. So I tried to set it up as a system of equations. That's what I had done previously, and trying to think about, we have 10 gallons of 3% vinegar. How much of the 9% vinegar would we need to add to that in order to make a 5% mixture? And so I guess, so the first one I tried was I did 10 times the 10 gallons times the 0.03 times X, because we don't know how many gallons of the 9%. When would it equal 5%? I came up with 2.8. So 2.8 gallons, that made sense to me, but then when I plugged it in, I got 0.5 instead of 0.05, so I still don't think that's right. I tried some other numbers, and still the closest, I still couldn't get it right. So then I tried something else. I tried a system of equations of 0.03a plus 0.09b equals 0.05. And if we add a plus b, we would have 10 gallons. Still don't know if that's right either. Then I just simplified that, and I got a negative 2.9. So I don't know on this one if I got it, like if I'm even close or in the ballpark. The last one, 27.5. These are actually my favorite kind of problems. I love them. So they tell us that 1 kilometer equals 6/10 of a mile. So if the pilot says the speed of the plane is 500 kilometers per hour, estimate the speed in miles per hour. So we basically need to change this into miles per hour. So I started with the 500 kilometers over 1 hour. And then I had to look up what the conversion was between miles and kilometers, and it's about 1.6 kilometers per every mile. Well, I'm trying to end up at miles, so I put my mile on top. And then that's 1 mile over 1.6 kilometers. It's got kind of messy there because I kept having to erase. And then so I cross out my kilometers, because now that's kilometers over kilometers, so that's 1. Then I multiply. 500 times 1 is 500. 1 times 1.6 is 1.6, and this is hours down here. This is miles up here now. So I divide 500 divided by 1.6, and I get 312 miles per hour, which makes sense to me. Now, can you convert the 500 kilometers per hour to feet per second? So I handled this in chunks. I took care of the miles and the feet first, and then I did the hours and the minutes. So there's 500 kilometers to 1 hour is what we're starting with. Then we multiply that times 1 mile over 1.6 kilometers. And then in 1 mile, we have 5,280 feet in 1 mile. Then I took care of because I still had hours available. So I have 1 hour and 60 minutes. And in 1 minute, there's 60 seconds because we're going from kilometers to hour to feet per second. So then I just go through and I cancel out my kilometers. I can cancel out my miles. And then I'm left with feet. I can cancel out hours now. And I can cancel out minutes. And so then I would need to multiply whatever's on top. So I have 500 times 1 times 5,280 times 1 times 1. And then I have 1 times 1.6 times 60 times 60 times 1. And then so I get this huge number of 2,640,000 feet per 5,760 seconds.